Okay, so I can start by demonstrating my motion detection. So I have a few helper functions and then a main function, but I'm going to start by commenting out the main function call, pasting in these few lines, which we're going to call my mask image function. So the mask image function, when I call it, I have this predefined region parameter set to none. Usually I would have it set to a certain array of vertices, but I have it set to none right here so we can define a new one. So when I click run, it should open the first frame. And then I'm going to go ahead and select a region of interest. I have 6 vertices as a parameter, so I'm going to go ahead and just select 6 on the right side of the frame. 1, 2, 3, 4, 5, 6. Okay, so now I have a new region of interest. I'm going to go ahead and copy this. I'm going to plug this up top into my global variable. And now this is the new region of interest. You go ahead and get rid of these 2 lines, uncomment the main function call. Now inside my main function, when I call mask image, I have the predefined region set to this predefined global variable that I have just pasted in these vertices 2 up top. So, okay, now I'm going to go ahead and call this or run this again. Now it's going to go through my actual motion detection with the region of interest being the region that I just selected. Go ahead and click run. I'm going to move myself out of the frame so that while it's running, I don't trip the motion detection. It's capturing a new frame each second while blacking out the rest of the image. So on just this right side, if I put my hand up, it's going to say motions detected. Okay, so motion's been detected. You can see on the bottom of the screen. It's now capturing a video, which will be sent, and it says email sent. So I'll go ahead and turn my camera on for this Zoom share so that the email will be shown. Okay, here we go. 4:13 p.m. I have another message. It's readable here. Oh, it's flipped. 4:13 newest message, and this is going to be the video that was just sent to me. So rather than, and this is me sticking my hand up. So rather than sending the first 2 frames, I decided it would be cool to just record a 5-second video and then send that to the email. So I can go now into explaining the whole program here. So my screen's still shared. Okay, I have a few imports up top. I start by declaring the webcam. There's a video capture object, and then the predefined region as a global variable, as I demonstrated before. Going into the mask image function, this is very similar from what we have in class, except I just have here that if this parameter is not none, then I'm going to go ahead and take what's given to it. Otherwise, like I just showed, I'm going to actually create a masked region using the fill convex poly function of CV2. So yeah, then I go ahead and I return the masked image, which is just a blacked out image with only the region of interest being shown. And those pixels are the only ones that are actually, their colors are saved. Then from there, I just decided to make a pre-processing function. This is unnecessary. Oops. Pre-processing function where I gray the image, put it into grayscale conversion, and I blur it using a Gaussian blur of kernel size that can be specified later. And then you resize it. I resized it to about 200 pixels, I believe, 200 pixel width. I chose a kernel size of 9, just because that seemed to be working well. It blurred, and I haven't really had any issues with it. I tried to blur kernel size of 5 and then kernel size of 13, but I just set some up with 9. Now into actually detecting the motion. So this is where I deviated a little bit from what was shown in class or the lectures we were given. So instead of just looping through every single pixel of the masked and resized image, I found that it would be much more efficient if you could loop through only the pixels in the region of interest. So rather than having a nested for loop where I loop through every column in each row of each image, I first call the np.numpy.where function, which will give me it will return two arrays, each one-dimensional array referring to the coordinates and XY values of the pixels that are within the region of interest. So using those coordinates, I can then loop through only for the length of one of those arrays, and then that will allow for a much more efficient motion detection. For example, one of the regions of interest that I made happens to be about 4,000 pixels, maybe 4,500 pixels in total. So now my function was looping through each frame only 4,000 times, whereas an image of width 200, height 200, it would be looping through 40,000 times. So we have a whole 10x reduction in the amount of iterations that were taken. That was for that region of interest. This one may have a little bit of a bigger size. But anyway, this is a much more efficient way, and it depends, the efficiency depends on how big your region of interest is, how many actual pixels it has. But this method of doing the image detection or the motion detection prevents just a continuous looping of every single pixel throughout every single pixel in the frame, especially the pixels that are already blacked out. So here I just do an absolute value of the grayscale values, the absolute value of the difference in grayscale values from the previous frame to the current frame. Just using this I as an index holder for the rows array and columns array. And this is that again, that is the pixels inside the region of interest. So the same call for the previous and for the current, just converting into integers so I can do subtraction. I get my grayscale threshold, I chose 50 just because I didn't have any issues with that. It was just a basic number I decided to go. Those can be tweaked for more or less sensitivity. Also detection count, I just chose 10. So if there are 10 pixels that have a difference greater than this threshold in grayscale, then that counts as a motion detected. I just print motion detected and return true. That's the majority of the motion detection. The next is just recording a video and sending an email. For recording a video, I just save it in MP4 file format. I flip the frame just so that it's easier to, it has a horizontal mirror effect. And then I write it, calling it output. Sending the email, this was from a video provided to us. I should probably not show this password, but I'll just delete it later. This is my email. So I log into the email here. Subject motion detected, sending the file. So I know I think the description in the assignment instructions said to send the first and second frame. I could have done that by just simply saving those two frames and then specifying those files here, but instead I thought it would be a little bit cooler and more realistic to send a 5-second, or you could even make a 30-second clip of the after motion was detected. Real quick up here, the duration of my video, I declare or I call when I call the function, and I specify that. But for the iterations and the amount of frames that need to be taken, a simple calculation of frame rate in frames per second times the duration gives me an exact 5-second video. I chose 20 frames per second at 5 seconds. So this is 20 times 5 iterations here. Now in the main, I simply just have a previous and a current frame, both initialized as none when I call the main function. And then this infinite loop here, I will capture a frame, making sure it's a valid frame. I'll flip it just as I said before so that it's easier for the user to see, mirrored effect. Masking it according to the predefined mask that I have up top. And then I set the previous equal to the current. Now, if this is the first loop, the current is going to be equal to none. So I'm basically setting the previous, which is already equal to none, now again to none. So that's why jumping down here to line 112 and 113, if previous is none, I simply pass this loop and continue so that I don't throw an error when I call detect motion on my previous and current frames down here. Yeah, so each time it loops, the current frame gets processed, and then, but right before that, the previous takes its place as a placeholder. So now I'm just comparing two back-to-back frames that are each 1 second apart. Yep, simply just showing them after they're masked and resized, um, detecting motion, and then if the motion is detected, I just record a video and then send the email like I showed before. In real life, in real application, I would probably remove this break statement just so that my Ring copy doorbell is just always running. For the purposes of this video, I included a break statement so that it would stop after my first motion was detected. And this was just for debugging purposes. While I was working, I can close out the window. Yeah, again, I chose a 1 second delay. I played around with it a little bit. I had no delay at one point. That was just recording all the time in real time. You have a 2 second delay, 5 if you want. I thought 1 was the most applicable. 1 frame per second before comparing images. Just so it's not constantly running at 20 or 30 frames per second. I think that's it. That kind of covers the entire script here. It was a really fun project. I'm glad that I got to play around with this and not just do a basic nested for loop that can be pretty inefficient. The whole reason we have a region of interest is so that we don't have to worry about things that are outside of it. So I thought it was a little bit of a waste of efficiency to still be checking for every pixel, even the pixels that were outside the region of interest. So I would say maybe to improve the algorithm even further in the future, I would split up the region of interest into multiple quadrants, 4 quadrants, maybe even 8 or 16 or 32 or however many. And with each iteration, I would check the first pixel of each quadrant, this way you don't have to start at one up top and then go all the way until you reach the other bottom corner. You could simply loop once, check, 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 loop again, check, 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 check. And the probability of you finding a motion detected probability of you finding it more quickly is higher because you're checking more areas of the frame instead of just going one pixel next to the other. So I would probably do that to improve the algorithm even further if I was to do this again in the future. Fun project overall. Thank you.